Today we are back with, back in fighting form. Looking at our...
This short video illustrates each step in a 50-minute active class about limit proofs in mathematics. The strategies you will see basically allow instructors to scale up optimal tutoring styles of teaching so they work with one instructor and many students.
So a typical lecture is not much of a lecture. I usually give 5 minutes of lecture at the beginning, which is review from the reading that they had last night. Sort of making sure that everyone is on the same page, trying to see if there are any sort of basic problems that I can work out. And so after 5 minutes of lecture or so, I put up the first clicker problem of the day. And we give them a minute or two to think about that, and we immediately go over it. And after the first clicker problem, the second one, they each take about 5 minutes. And then after the clicker problems, there's what I call a challenge problem, so a more difficult, in-depth problem. They have 5 or 7 minutes to work on that individually, and then another 7 to 10 to work on that in small groups. The rest of the lecture is going over their solutions to that challenge problem posted on .cam, talking about what went well in the solution and what sort of didn't work or what needs to be corrected in the solution.
Now let's see these components in action during the real class, starting with a short Socratic lecture.
We just need this to be always true? Yeah.
Like given the delta that we choose.
Yeah, so we need... So given a delta, so there exists some delta such that this is true, or what's the...
Such that like x minus 1.
Okay. That's right. 0 is less than x minus 1 is less than delta. And then how do you connect these two ideas?
But you want to turn, you want to get the bottom one in terms of x minus 1.
Next, 2 clicker questions are used to help check on basic comprehension and address any difficulties.
Given this, let's take a look at our first clicker question. We are spread this morning. Okay, so what's an argument there? Why is A going to be all right? Yeah.
X minus 1 is greater than negative 3 over 4.
So you're saying that this means x minus 1 is going to be...
Getting that immediate feedback, both from the clickers and getting the immediate feedback from solving the challenge problem, is really important. It helps me see right away the sort of mistakes they're going to make, and helps them get that feedback. I think there's a real difficulty in receiving feedback from homework because by the time they hand it in, it gets marked and it gets sent back to them. It's been a week or 2 weeks between. There isn't the same sort of immediacy or connection, whereas if you are working on a problem right now and you get feedback, the lesson's going to get learned a lot better, I think.
Yeah.
Clicker question discussions involving as many students as practical take 4 to 5 minutes each. Then the challenge problem or group activity is introduced.
So let's take a look at today's challenge problem. Go right from the beginning, working in small groups.
The top one.
Yeah.
So what if we said...
We get even actually because
The instructor circulates to listen and guide thinking. Teaching assistants can help in large classes.
There were a lot of challenges teaching this way. The most difficult was finding ways of using your time productively while they were working on these challenge problems. It's hard to know how to facilitate their learning from each other. I mean, it certainly isn't something that you're taught as an educator. Something I had to pick up as I was doing it. At the very beginning of the semester, we were discussing one of these challenge problems. We were all reading over someone's proof, and I realized a mistake that someone made, and realized that it was something that I wouldn't have been able to come up with myself. And there was a great moment to explain this is a really common error, but not one that I would have remembered to have brought up by myself. So this is a great opportunity for them to learn. I was learning something too. I was getting a much better understanding of how they were approaching the topic that I wouldn't have seen from the homework. First clue to me that I was really on the right track. This was going to work.
Okay, so let's take a look at one of our solutions. So, what do you think is effective about this proof?
I follow up to the simplifying of the fraction.
Okay.
All the way up to the line where it says the inequality with the fraction and smaller than 2/3 epsilon. The one below your thumb. Yeah, I follow up to there. I follow up to the end of your thumb, and then after that, I'm a little left.
Okay, so we know that. I mean, we're trying to show this is less than epsilon, right? We don't know that this is less than epsilon. So as far as constructive criticism goes, the first thing I would...
Running classes this way is certainly more rewarding for instructors, but students also recognize the many benefits.
The way it functions is we actually do reading on the subject we're going to talk about in class first, and then come in and work on it. You know, some math classes you're just kind of, a lot of information is thrown at you and you're not quite sure of the context or how to use it or that kind of thing, but getting a little reading in first and then using the class time to kind of practice, to me it makes it a lot more clear.
This video has illustrated how one instructor uses various strategies to more effectively engage with his students in the classroom. These evidence-based practices can be applied in basically any type of course, and most instructors find they develop these skills quite quickly.